In this video, we'll solve LeetCode 1984, minimum difference between highest and lowest of k-scores. This is an easy problem on paper, but it tests whether you truly understand how sorting simplifies optimization problems, which is a core interview skill. You're given an array nums, where each value represents a student's score. You're also given an integer k. Your task is to pick any k students such that the difference between the highest and lowest score among them is minimized. In short, pick k elements. Minimize, max, selected, minus min, selected. The important thing to notice is this. When we care only about the maximum and minimum of a group, the relative order of elements matters more than their original positions. This strongly hints at sorting the array first. A brute force approach would be to try all possible combinations of k students. Total combinations, CNK. Exponential. For each combination, compute max and min. This is not feasible even for moderate input sizes. So instead of checking all combinations, we need a smarter way to narrow down our choices. Why sorting works. Once the array is sorted, any group of k students that minimizes the difference must be contiguous in the sorted order. Why? Sorting places similar values close together. The smallest possible range will always appear inside a window of size k. So the problem becomes, among all contiguous subarrays of length k, find the minimum value of this expression calculates the difference between two elements in the array nums. It takes the element at position I plus k minus 1. Subtracts the element at position I. That's a sliding window on a sorted array. Let go for example. Nums is a list containing the values 9, 4, 1, and 7, and k is equal to 2. Step 1. Sort the array. The sorted array is 1, 4, 7, and 9. Step 2. Use a sliding window of size 2. Window 1, 1 and 4, the difference is 3. Window 2, 4 and 7, the difference is 3. Window 3, 7 and 9, the difference is 2. The minimum difference we can achieve is 2. Now the code defines a solution class with a function called minimum difference that takes a list of numbers and an integer k, and returns an integer result. If k is equal to 1, the function immediately returns 0. The list of numbers is then sorted in ascending order. A variable called min_diff is initialized to a very large value. The function then iterates through the list using a sliding window of size k. For each window, it computes the difference between the last and first elements in that window and updates min_diff with the smaller value. Finally, the function returns the minimum difference found. Time complexity, O of n log n due to sorting. Space complexity, O of 1 extra space, ignoring sort internals. This is optimal and fully acceptable within the constraints. Anytime you see, pick k elements, minimize max minus min, closest values, your brain should immediately think, sort first, then slide a window. This pattern appears everywhere in interviews. To summarize, we sorted the array, used a sliding window of size k, tracked the minimum range. Simple, clean, and interview perfect. If this breakdown helped you, subscribe,